Hello, this is Professor Arai in section Evaluate Finite Differences. In this section, we will be looking at charts, evaluating patterns, and finding their equations. This technique is used by meteorologists to predict temperature of a certain day. Basically, they look at data at previous years and places to establish a weather pattern that can aid them in making their own prediction. The theme that this section falls under is called organizing information. And the whole purpose of this section is to find an equation for polynomial functions. Polynomial functions can be linear, quadratic, cubic, and so on. It all depends on the degree of the polynomial. And the degree of the polynomial is the largest power of x that is in the polynomial. So in this case, I only have one x in here, and the number above the x is 1. So this is a linear function. In this case here, the degree is 2, so this is quadratic, and so on. So let's look at the first portion of this chapter, linear function. Linear functions are represented by lines, and the equation of any line takes this format, y equals mx plus b, where m is the slope and b is the y-intercept. And since the goal of this chapter is to look at the chart and find the equation, we will use the name of this chapter, finding differences of finite values. So this is what we will do. We will look at the y values and find their differences. And the way you will do it is you will take the second value and go up. So you'll go from bottom up. Now before we start taking differences, I just want to note that the first input of x needs to be 0. And I'll show you in a minute what happens if the first input is not 0. So since my first input is 0, I'll go ahead and start subtracting. So 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So I start to see a pattern of constant number. And this happened after I took the first differences. So this constant number in this case, which is 3, is the slope of the line. The other value that I need to know is the y-intercept, b. And the y-intercept is the value of the y when x equals to 0. So in this case, when x equals 0, y is 1. So the equation of this line will be y equals 3x plus 1. Now we were able to determine that this table represents a linear function because the numbers were constant after taking the first difference. Now if the numbers were not constant, then I would have to take the second difference. And in this case, my equation will be a quadratic equation. But we will see this in a minute. So let's see more tables of linear functions. Look at this table over here. Again, you start subtracting from bottom up. So 7 minus 9 is negative 2. And 5 minus 7 is negative 2. And if you keep subtracting, you see a constant number after taking the first difference. And since you're getting that after the first difference, then this is a linear equation that takes a form of y equals mx plus b. This constant is your m. And b is the value of the y when x is 0. So the equation in this case will be y equals negative x plus 9. Let's look at another example. Again, you take the differences and you see that you're getting a constant number. So this is your slope, the m. So y equals 1x, or you don't even have to write it. You can say y equals x. And then the b. The b, again, is the value of the y when x equals 0. In this case, the b is negative 4, so the equation is y equals x minus 4. So let's do an example. Find the equation of this function, then find the value of y when x is 5 and when x is 137. So look at the first input of x is 0, so you can proceed. Take the difference. 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4. I start seeing a constant after taking the first difference. That means this is a linear equation. Linear equation needs a slope, which is the constant number, and a y-intercept. which is the value of the y when x equals 0. So in this case, this is my slope over here, m equals 4, and the b equals 3. So the equation is going to be y equals 4x plus 3. Once you know the equation, you can find any value of the y given x. So the question was, find y when x equals 5. So all you have to do is plug in 5 for x. So 4 times 5 is 20, 20 plus 3 is 23. So the value of the y is 23 when x equals 5. Similarly, the y will be 551 when x equals 137. Okay, the second portion of this chapter is quadratic function. And for this, you need to remember the format, the general format, and the general chart. And I'll talk about this in a second. Now, the general format for an equation is like this. Y equals some number, we'll call it g, x squared, plus some number, we'll call it f times x, plus a number, we'll call it e. So this is how the equation should look like. The general chart is generated by using the general format and plugging values for x from 0 all the way to 4. So when x is 0, this becomes 0, this becomes 0, and the y will be e. And then when x is 1, this is g times 1, that's g, plus f plus e, so this would be the value over here, and so on. And they gave you the differences in each case. Now, let's see what happens. What's the difference? So in this portion of the chapter, you will take the difference and you will find that the first difference is not constant. And when this happens, you will do the difference one more time. In this case, we found the difference to be constant in the second time. And since we find the difference to be constant in the second time, it means this equation or this table represents a quadratic equation. So remember, in the first portion of this chapter, the first difference was constant, and that's why it was a linear equation. In this here, I have the second difference is constant, and this is why this table represents a quadratic function. So once you know that this represents a quadratic function, you really need to have your master chart with you. And basically, you'll compare these values from here to these values from here. And the easiest way to do this, you will look at the furthest point of the chart and compare it to the furthest point from your number chart. So in this case, I can see that 2g equals 1. That means g is half, and g is the first value. And I can look at this row over here, g plus f equals 0. G is 1/2. That means f will be -half. And e can be taken from the first row. When x equals 0, the y equals e. So when x equals 0, the y equals 0 in this case. That means e is 0. So once you have the values for g, f, and e, all you have to do is plug it in. In this case, the equation will look like this. Y equals 1/2 x squared minus 1/2 x. We will see more examples to get this in a better way. Example 2. Find the equation for the function displayed in the chart, then use your equation to find the missing y. Okay? Don't get overwhelmed. We'll do this together. So let's see. You're given a chart. Your first input is 0. Perfect. So you start subtracting. You start subtracting the y values. So -2 minus -5. You'll have +3. And you'll do it again. 5 minus -2, you'll have a +7. So you keep finding the differences, and you find that the first difference is not constant. That means I need to take the differences one more time. So you start subtracting again. So this time you'll do 7 minus 3, that's 4. 11 minus 7, that's 4. And so on. So you'll find that the second difference is constant. Once you find that the second difference is constant, that means this chart represents a quadratic formula. So your next step is to compare your table with the master chart. So you'll put your table here and you'll compare it to the master chart. So let's do this. Start with the furthest point. 2g equals 4. That means g is 2. And this is the first value. G is 2. When x equals 0, y equals e. So that means that e equals -5. So I have the second value. Now I just need to find the third value, which is the f. I can find it using this rule. G plus f is equal to 3. Now I know that g is 2. 2 plus f equals 3. That means f equals 1. Once I have all three values, I need to remember the general form. Remember, the general form or the general equation looks like this. Y equals gx squared plus fx plus e. So g is 2, plug 2 in there. F is 1, so you plug it in there or you don't have to. And the e is -5, you put it in there, and this would be the quadratic formula. Y equals 2x squared plus x minus 5. The next part of this question was to find the y value when x equals 48. So all you have to do, you will plug in 48 in your equation and solve for y. In this case, y equals 4,651. Okay, let's see another example. Example 3. Suppose that at the first meeting of the House Representatives, all 435 members shook hands with each of the other members. How many handshakes took place? Now notice here you are not given a chart, and you will have two problems in the homework like this. You will first have to develop a chart, then you will look for a pattern. Let's do this logically. If we don't have any person in the meeting, then no handshake will happen. And if you have one person, that person is not going to handshake himself or herself. If you have two people, then there will be one handshake. If you have three people, you will have three handshakes, and so on. Once you have your table, you can start taking differences. So 0 minus 0 is 0, 1 minus 0 is 1, 3 minus 1 is 2, and you notice that the first difference is not constant. You'll have to do it again. So 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1, and you notice that the second difference is constant. That means this will follow a quadratic formula. So your third step is to compare your table to the master chart. So one more time, I'm going to start from the end. 2g equals 1, that means g equals half. G plus f equals 0, and g is half, that means f will be -half. And e will be taken from here. When x equals 0, this is the value of e. In this case, the e is 0. Once you have the g, the f, the e, you can plug it in. So y equals g, which is half x squared, plus fx. F in this case is -half. So you'll write, instead of plus, you'll put minus half times x plus the 0 for the e, but you don't have to do that, so you'll stop and this will be your equation. Now we are not done because the question was how many handshakes. The number of the representatives is 435 and the y represent the number of the handshakes. So you'll find the value for the y when x equals 435. Plug in there in this equation and you'll find that there are 94,395 handshakes that took place. Okay, the third portion of this section is the cubic functions. And even though it looks more complicated, it honestly follows the same pattern. So you will also have to have your own master chart with you every time you do the equation, as well as the general format of the equation. So for the cubic function, the equation will look like this. Y equals hx cubed plus gx squared plus fx plus e. So we actually have to find the value of h, g, f, and e, 4 values. And the master chart will be given to you. And again, we will start from the end and we'll walk our way until we get the e. Keep in mind, e is the value when x equals 0. So let's see an example. Example 4. You are given a chart and they already took the differences for you, and the first wasn't constant, the second wasn't constant, and the third was constant. Since we have the third to be constant, then this is a cubic function and I need to compare it to the master chart. Now, to add to the complication, the value when x equals 0 is not there. That means I'm missing one row from the top. So when you compare your numbers, you are comparing it, let me pull that chart, you're comparing it to the values from here, from x equals 1. So anything down. So I cannot see this row, I cannot see this equation, nor this equation. So you'll start from here. When x equals 1, you have value here, and then you have this value, this value, this value, and so on. So let's do this together. Start from the end. 2. 2 is actually the 6h. So 6h equals 2. That means h equals 1/3. Good. I have the first value, 1/3. Next goal is to find the second value. So I need to use something from this column. So again, I cannot use the first row because the whole row doesn't exist in my table. My table starts with x equals 1. So I need to follow that. So my column here, even though I see 5 as the first value, when I compare it to the master chart, 5 is actually over here. So I need to follow this equation, 12h plus 2g. You can write this master chart by yourself and erase this row. Once you erase this row, you cannot subtract. So you don't have this and you don't have this 6h plus 2g. So I'm starting from here. So 12h plus 2g equals to 5. And I know h is 1/3. So you plug it in. 12h plus 2g equals 5. The h is 1/3, so 12 times 1/3 is 4, plus 2g equals 5, and g equals 1/2. So now you have the second value. Now to get the third value, you will use this column. This is where the f starts to appear. So one more time, I don't have this row, so I have this row, and this is what I'm going to use. 7h plus 3g, I already know h, I already know g, I need to find f. What is this value? I will take it from my chart. It is 4. So you'll say 7h plus 3g plus f equals 4. Plug in h, plug in g, and find f. And f is 1/6. Now I'm only missing the e. So one more time, I'm going to go back here. I don't have the first row, so I'm using this row. I know h, I know g, I know f, so I need e. What is this equal to? I need to look at my table. It's equal to 1. So you will say h plus g plus f plus e equals 1. Plug in the value for h, the g, the f, and find e. And you'll find e to be 0. Once you have the 4 values, you will plug them in your equation. So the format is y equals hx cubed. So instead of h, you'll put 1/3 plus gx squared. And instead of g, you'll put 1/2 plus fx. And instead of x, you'll put 1/6 plus e. But e is 0, so you don't really have to write it down. So again, it looks complicated, but it honestly follows the same pattern. All you have to do is to put these master charts next to your table and compare the values. Remember, when you are doing cubic functions, this column gives you h, the second column from the right gives you g, third column from the right gives you f, and the fourth column from the right gives you e. So in the homework, you'll have to do all three of them. So the next two slides, you have the summary of the whole process. But in general, the whole process is honestly to look at the chart, find the differences of the y values. If the first differences are constant, then this is a linear equation. That means you need the m and the b. If it's not constant, then you have to do it again. And this, if the second time it's constant, then this is a quadratic equation. And you have your master chart to compare it to find the values. And same thing with the cubic functions. Now in the homework, you are given 3 tables, one from each function. So you'll have to compare it to your master functions to do this. But you should be able to find, because it really follows the same pattern of example 1, 2, and 3, and 4. The second and the third problems in the homework, for those problems, you need to build your own chart first. So in this question, it says find the formula for the triangular numbers and then find the number of dots in the 87th figure. So the way you will build your chart, you'll say my first triangular number. So you have a relationship between triangular numbers and numbers of dots. So you'll have a table. The first column will be the numbers. Basically, you'll say 1, 2, 3, 4, and 5. And the second column will be the dots for each of those numbers. So for number 1, you'll have 1 dot. For number 2, you'll have 3 dots. For number 3, you'll have 5 dots. So once you build your own chart, then you'll do differences and find the pattern and find the equation. Same thing with number 3. You will have a relationship between the rectangular numbers and the number of dots. Again, you'll have to build your own chart and then find your pattern and your equation. Once you find those equations in number 2 and 3, you need to find the y value when your x equals the given question over here. So for this one's 87 and for this one 73. It's a lot of arithmetic, but hopefully it's not that complicated. Please try to do them by yourself. If you're having any trouble, let me know. But that's it for this section. Take care.